Hi, in a previous video lesson we explored how to use the concept of substitution to help us solve a linear system, especially when the linear system is presented to us in the standard form instead of slope-intercept form. First of all, there's two steps to the process of solving linear systems in standard form. The first is to graph using the Intercept method, which requires some documentation so we know what your thought processes were. I find the x and y intercepts for the green equation, and I find the x and y intercepts for the red equation, which enable me to graph really easily. Then there is the actual algebraic solving of the system. For this there are two techniques. The last video we talked about substitution, where I solve this equation for y, and then I substitute that value into the second equation so that now my equation only has x's in it. Now I can continue to solve and I get x equals 2. Then I go back to my first equation and find y equals -1. And then to verify that the solution to 2, -1 is correct, I go back to the other equation and show that it actually works, which is what I predicted. So everything's copaesthetic. Now for the next method, we're going to apply a different approach, not to the graphing. The graphing process is identical. Making a prediction from your graph, same as always, same as it ever was. But here, if we're going to solve using a different technique, instead of substitution, we're going to use a technique called elimination. What we're going to do is we're going to add the right-hand side and the left-hand side of each equation together to make one of the variables go away. Unchanged, if I add the left side, I'll get 5x plus 2y equals 8. And you see by adding the two equations together, I create a new equation, but it still has two variables in it. Instead, I'm going to be a little sophisticated. I'm going to triple all the values in the first equation to produce a new system that looks like this. Now, when I add the the equations together, left and right hand sides, I get 11x plus 0y. So now the y is dropped out, and I'm left with x equals 2. Third step in the process, now go back to one of my equations, substitute 2 for x right there, and find the value of y. Y is -1. So now I know the solution is 2, -1, just like it was before, and the same as before, I'm going to check using the other equation to make sure that that's right. Ignoring the graphing part, I did all the work graphing with technology. Here's a different system, and I solved the system digitally and found 1/3 negative, maybe 1/6 or something, as the solution. So I only did this example not to focus on the graphing, but just to show you again another example of the elimination method. Notice that when I add these equations together as is, none of the variables would drop out. I'd still have a two-variable equation. Notice also that there's not one single value that I can multiply one equation by to make to make a variable go away, unless that value happens to be a fraction. But I'd like to avoid that. So, using the elimination method, I am going to choose to multiply the first equation by 3 and the second equation by 2. The goal being, I want this to be 12y and this to be -12y. Now I chose in this case to make the y's disappear because one's positive and one's negative, and that's going to make my work a lot easier for me. Here both the x's are positive, I would have to make one of them negative and thereby make every term negative and increase my chances of mistake because of all that negativity. So, needless to say, when I distribute here, I'm going to end up with a system that now looks like 15x plus 12y equals 3 and 6x minus 12y equals 4. When I add the two together, I get 7 on the right-hand side, and I get 21x on the left-hand side, and solve and get x equals 1/3. Normally I'd be nervous because it's a fraction, but I already solved it, and I know x was 1/3 to begin with, so I can confidently proceed with the process. This is not the solution to the system, it's just the x value, so now I need to go back and find the y value by substituting 1/3 in for x and doing some very simple algebra. Y equals -1/6. So the solution appears to be 1/3, -1/6, which matches my digital. And then just to make sure, I go back to the other equation, the one that I didn't use for part 3. I go to the other equation and show that 1/3, -1/6 is also a solution to that system. So that makes me feel good. Hope this was helpful. I know I went really fast. Please pause and rewind and study the stuff till you understand what we're doing here. So just as a last little minute summary, remember there are two processes here in the process. There's a graphical solution, which requires a little bit of annotation, and when we do our work we should show that this is the information we gathered to graph. Then there's the method of algebraic solution. I'm asking that you number your steps so anybody can follow from one step to the other what you did. Finally, state your solution to your system clearly as an ordered pair. You do all these things, you'll be fine and successful, at least in this class. Thanks for watching. Have a great day.